G'day, James here with the Selecting for Carbon project. Today I'll be walking you through the use of your map book and how it can guide you in identifying areas of your property that will respond well to grazing and water management, as well as through enhancing ground cover. We call these areas responsive zones, and if managed appropriately, they should offer the best chance at increasing your soil's carbon sequestration rate. Now bear in mind that these maps are to be used as a tool. They won't give you the answers on their own. Some of the maps might not be 100% accurate because the data used to make them was collected some time ago. Other maps are built using modeled data, and that modeling happens at the state level, not the local level. With this in mind, it's best to consider these maps as an estimate of your soil's potential for carbon capture. Now, the relative differences you see between the various maps of your property should be consistent. So use these maps as a guide, but also incorporate your own knowledge of the land. This should offer the best path to success. All right, let's go on a quick tour around one of our maps. At the top right, we have the title, including the station name and what the map is actually measuring. Beneath that, we have a brief explanation of the same. If we move down, there's the reference to where the data came from. So this includes the authors, the publication date, and the website that the data came from. Beneath that, we have the map legend. Then over here, you have your compass, where north will always be pointing to the top of the page. And finally, we have the map scale. Now, for some soil measurements, clay percentage for example, we've included 3 separate maps to show you what's happening as you dig deeper into the soil. If you see these symbols during the presentation, then you'll know there's 3 maps for that soil measurement included in your map book. All right, let's jump in. So first up, we have the woody cover map, which can help with orienting yourself. The blue signifies areas of sparse woody vegetation, where there's between 5 and 19% canopy cover, and the green signifies areas where there's more than 20% canopy cover. Now, do note that the data for these maps is quite dated, so you might have to assess your land and update it with a bit of blue or green highlighter. Next, we have the digital elevation map. Use this map to have a think about the flow of water and nutrients around your landscape. Think about where there are ridges and how you might treat them differently to alluvial flats. Next, we have the range type and major range type maps. These maps can be helpful when comparing your property to a neighbour's or if you own multiple properties. They'll give you a chance to compare apples to apples and floodplains to floodplains. Next up, we have the cation exchange capacity, or CEC. Now, CEC is a useful indicator of soil fertility. Among other things, it shows your soil's ability to supply 3 important plant nutrients: calcium, magnesium, and potassium. These nutrients are positively charged ions, known as cations, and CEC is essentially a measure of the soil's ability to hold on to these nutrients by electrical attraction. The CEC of soils varies according to clay content, the type of clay present, soil pH, and organic matter content. Pure sand, for example, has a very low CEC. Now, CEC isn't something that can be easily changed, although low CEC values can be improved by building organic matter. Next, we have our map showing percentage clay content. Clay is heavier country and sand is lighter country. Clays are negatively charged, so they hold on well to those positively charged cations I just mentioned. Now, in heavy clay country, it can take more water to wet out the soil, but the soil will remain wetter for longer. So this is just a good point to keep in mind. Following on, we have soil pH. Now, soil pH is also important for helping the soil hold on to those nutritious cations. As pH increases and the soil becomes less acidic, the number of negative charges on the soil also increase. This allows more cations to be retained by the soil, which will influence the types of plants that grow. So these pH maps are a good way of thinking about your land as different zones. Keep in mind that soil pH below 5.5 at the surface and 4.8 in the subsoil are going to limit the potential for plant growth and biomass production. Now, soil pH significantly influences total organic carbon content because it regulates that nutrient bioavailability, so how quickly the microorganisms can get in and start, utilizing them. Also influences organic matter turnover and a number of other soil processes. Definitely a good thing to have a look over. Moving on, we have soil organic carbon mass. As you're likely aware by now, organic carbon is important for agricultural production because organic matter helps to improve soil structure and its capacity to exchange cations and hold water. Now, bear in mind, this data is modeled at a state level, not using local data. So, consider it as, what your soil's potential for carbon capture might be. You want to be considering which zones are likely to see an improvement in their soil organic carbon contents and focus the use of different land management practices in those responsive zones. The final map shows data modeling of soil organic carbon stocks. This is a single map calculated in tonnes per hectare and measures the soil organic carbon content to a full depth of 30 centimetres. All right, I hope this presentation has been helpful and I thank you for your time. Have a great day. Cheers.